So in this video, I'm going to use the algorithm that involves augmented matrices to solve this linear system. That algorithm is to take a linear system, write it as an augmented matrix, reduce that matrix using row operations to reduce row echelon form, then write the reduced matrix as a linear system, which is going to be equivalent to the original linear system, but can be solved by inspection. Okay, so without further ado, let's create the augmented matrix. Okay, so here's the augmented matrix corresponding to the linear system. Notice that the coefficients have been faithfully reproduced. So the idea is to get the matrix in reduced row echelon form by using row operations. What are those row operations? Well, we could interchange any two rows. We can multiply any row by a non-zero constant. And my favorite, we could add or subtract a multiple of any row to another. Okay? Let's proceed. So we notice that we have a leading 1 in row 1, and we're going to use that to get zeros elsewhere in that column. As desired for the process of moving towards reduced row echelon form. Okay, so what are we going to do? Well, using the row operations, I'm going to let row 1 stay intact. All right, so row 1 stays intact, and then I'm going to first subtract 2 row 1s from row 2. Thus, row 2 is going to get replaced with row 2 minus 2 row 1s. Okay, so 2 minus 2 1s is 0, negative 1 minus 2 negative 1s is 1, negative 3 minus 2 negative 2s is 1, 2 minus 2 1s is 0, negative 6 minus 2 zeros is negative 6. Okay, now I'm going to replace row 3 with row 3 plus row 1. Okay, that'll eliminate the negative 1 here. All right, so that gives me a 0. Negative 1 plus 2 is 1. Negative 2 plus 1 is negative 1. 1 plus 3 is 4. And 0 plus 2 is 2. Okay, finally, for this leading one, I'm going to replace row 4 with row 4 minus row 1. Okay, so 1 minus 1 is 0, 1 minus negative 1 is 2, negative 1 minus negative 2 is 1, 2 minus 1 is 1, and 1 minus 0 is 1. Okay, so we're making progress towards reduced row echelon form. To proceed, notice that we have a leading 1 in row 2. So we're going to use that to get zeros elsewhere in that column. Okay, let's see what we have to do to make that happen. Well, row 2 stays intact. 0, 1, 1, 0, negative 6. All right? And so what I'll do is replace row 1 with row 1 plus row 2. Simple as that. All right? And then I'm going to replace row 3 with row 3 minus row 2, right, to get rid of this one here. And then I'll replace row 4 with row 4, okay, minus 2 row 2s. Okay? So row 3 gets replaced with row 3 minus row 2. This should be a 2 there. Okay? All right, so let's do it. So row 1 will add row 2 to row 1, right? So 0 plus 1 is 1, 1 plus negative 1 is 0, 1 plus negative 2 is negative 1, 0 plus 1 is 1, and negative 6 plus 0 is negative 6. All right? Good. Now row 3 minus row 2. Okay, 0 minus 0, 1 minus 1 is 0 as desired. Okay, and then negative 1 minus 1 is negative 2. 4 minus 0 is 4, and 2 minus negative 6 is 8. Oh, nice. Okay, so we have, we have all even numbers in row 3, so I'm going to take advantage of that fact in a second. So let's see what we have with row 4. Row 4 minus 2 row 2's is 0. 2 minus 2 1's is 0, again as desired. 1 minus 2 1's is negative 1. All right. 1 minus 2 zeros is 1. Right, this is negative 1. Right, neatly there. And then 1 minus 2 negative 6 is 13. All right, so we're getting there. Okay, to save space, we'll begin with the last augmented matrix we obtained, all right, in our journey to produce augmented matrix in reduced row echelon form. All right, so I noticed that if I divide row 3 by negative 2, I'll get a leading 1 in row 3. So I have a 1 here, a negative 2 here, and a negative 4 here. All right, so to get zeros elsewhere in this column, I'll replace row 1 with row 1 plus row 3. I'll replace row 2 with row 2 minus row 3. And I'll replace row 4 with row 4 plus row 3. Okay? And that'll give me zeros elsewhere in the column. Let's see what we yield. Okay? So we have row 3 remains intact, negative 2, negative 4. And so I add row 3 to row 1, and what do I get? A 1, right? I get a 0. I get a 0 as desired. I'll keep this up high here. Negative 2 added to negative 1 is negative 1, and negative 4 added to negative 6 is negative 10. All right. Now, row 2 minus row 3, what do we get? 0. We keep our leading 1. 1 minus 1 is 0, as desired. 0 minus negative 2 is 2, right? And 6 minus negative 4 is negative 2, right? Right. All right. 6 minus negative 4 is negative 2. Good. Now, finally, for this cluster of operations, I'll add row 3 to row 4, right? So 0, 0, 0, okay, negative 1, 9. All right? Good. So we're getting there. If I multiply row 4 by negative 1, I'll have a leading 1 there that I could use to get zeros elsewhere in this column. So what am I going to do? The operations to do that will be take row 4 and add it to row 1. So row 1 gets replaced with row 1 plus row 4. Row 2 is going to get replaced by row 2, okay, minus 2 row 4s. And row 3 is going to get replaced by row 3 plus 2 row 4s. Okay, let's see what we yield. This should be the final step in reduced row echelon form. Okay, so we have row 4 added to row 1. No problem. 1, 0, 0, 0, negative 19. Okay? Row 2 minus 2 row 4s. Let's keep row 4 intact, right? There we go. So row 2 minus 2 row 4. So that's 0, 1, 0, 0 as desired. And negative 2 minus, right, 2 groups of negative 9. So that's negative 2 plus 18, which is going to give me 16. All right? And then finally, row 3, I add 2 row 4s to row 3. So what do I get? 0, 1, 0, 0 as desired. 2 1s to negative 2 gives 0. And 2 negative 9s to negative 4 gives me negative 18 plus negative 4, which is negative 22. Okay, so we have reduced our augmented matrix to reduced row echelon form. You see this is a reduced row echelon form. The one staircase down, whenever there's a leading 1, there is 0 elsewhere in the column. Okay? And every non-zero entry in each row is a 1. Okay, so let's go back to the world of equations, right? We're going to write the augmented matrix as a linear system that, first of all, can be solved by inspection, and second of all, it's more importantly, its solution is going to be the same as the solution of the original linear system. Okay, so let's erase all this stuff and then rewrite the augmented matrix as a linear system. Well, of course, that's very straightforward. We have x is equal to negative 19. We have y is equal to 16. We have z is equal to negative 22, right? And then we have w is equal to negative 9, right? Okay, so the solution then is just a single point in four-dimensional space. We have negative 19, 16, negative 22, and negative 9. Good. So the next step is to, check our solution and make sure that the solution we obtained is the solution to the original linear system. All right, so let's do that. Okay, so what do we have? We have negative 19. Negative 16, negative 2 times 22 is positive 44, and negative 9, and we want to see if that's equal to 0. Well, let's collect the negative people, right? So negative 19, negative 16, I'll just add them together and make them negative. 19, 16, and 9, so we have 9 and 6 is 15, and 9 is 24. Right, carry the 2, and then we have 44. So we have negative 40, perfect. Negative 44 plus 44 is equal to 0, check. Okay, because these people are negative 44. All right, let's check equation 2. Okay, so equation 2, we have 2 times negative 19, that's negative 38. Minus 16, okay, and then minus 3 times 22, so that's positive 66, all right, and then 2 times negative 9 is minus 18. So once again, and so all this is supposed to equal negative 6. So let's collect the negative people and add them up. All right, so we have negative 38, negative 16, negative 18. So 8 and 6 is 14, and 8 is 22. So we carry the 2, and then we have, all these are going to be negative, so I'll just make them positive and change the sign at the end. So we have 5, 6, 7, 72, right? Okay, so the negative people add up to 72. So we have negative people, we have negative 72, okay, plus 66, and is that equal to negative 6? It sure is, right? Good. Negative 6 equals negative 6. Perfect. Equation 2 checks. Let's check equation 3. All right, so what do we have? Negative 19 is positive 19. 2 times 16 is 32, right? Then we have z, which is negative 22, all right? And 3 times negative 9 is negative 27. And we want that to all equal 2. Well, let's see. Let's add up the positive people and the negative people. 19 plus 32 is 51, right? And is 22 plus 27. What is that? So 22 plus 27, that's 49, right? So 52 minus 49 indeed is equal to 2. Good. And finally, for this process of checking, we'll look at the fourth equation, right? So we have negative 19, we have positive 16, we have positive 22, and we have negative 18, right? because that's 2 times negative 9, and that's supposed to be equal to 1. Let's see what happens. Well, the 16 and 22 gang up together to be 38, right? So we have negative 19 plus 38, right, minus 18. I'll take advantage of the fact that 38 minus 18 is simply equal to 20, right? So negative 19 plus 20 indeed is equal to 1. And our solution checks.